test we're going to conduct as part of the field assessment is what's called vertical deformation, and it's really the softness test. It's what you feel underfoot. Natural grass will produce, using this device, vertical deformation of between 7 and 11 millimeters. So it's really a sweet spot of stiffness that we're looking for here. We're going to drop it 3 times in the same location, similar procedure to the GMax test with a slight pause between drops. Drop 1. Oh. Drop 1 gave us a vertical deformation of 10.2 millimeters and force reduction of about 71. Force reduction, you're really looking in the range of 50 to 70%. In new fields, what you'll typically see is more force reduction in other words, a softer field, so higher vertical deformation, more force reduction. Over time, as the infill consolidates and this field gets more play and activity, both those numbers will go down. So 1 to 2 millimeters in vertical deformation and force reduction will fall down in the 70% range. We'll do a second drop. Vertical deformation is now 8.7 millimeters, force reduction 69.7. So what we've done is consolidated the infill a little bit with that first impact, and now we're starting to see what we would really expect over time. We'll wait a couple more seconds, do the final impact. And then what we do is we average the second and third impacts on this field. Oftentimes with GMax and systems like this that use a flat missile, the first drop is a conditioning drop, which means basically consolidating the material, and the second and third drop are the actual readings. So we have a vertical deformation of 9 millimeters and force reduction of 69.7. So we are at the upper limit of force reduction, which is good, because as it tightens up, force reduction will go down and fall within that 50 to 70 range. And then vertical deformation at 9 will ultimately end up maybe in the 7 millimeters, which is a fast, firm field. This is an NCAA Division I facility, so these guys are going to want something that's safe to fall on, but fast to run on. Thank you.